Welcome to Unit 1, Lesson 9. We are going to be doing more quadratics, but this time we're going to be focusing more on what they look like and how they behave. And we are not going to be focusing so much on the standard form. Rather, we are going to be talking a lot about the vertex form. All right? And then we're going to have some new material here. And let's just dive right in. That's the best way to do it. So, okay, I think we've seen this before on how our graph of x squared could move, right? K talks about vertical movement up and down, and H talks about horizontal movement left and right. But more specifically, this is called the vertex form because they literally give us the vertex in the equation. Okay, here's the K, that's the Y value of my vertex. Okay, here's the H, that's the X value. Just be careful. Anytime something is in parentheses, it is always opposite. So if those parentheses had X minus 3, all right, and then I had a 5 out here, let's say, well, K is 5, but my H is positive 3. It's not negative 3. Okay? So whatever sign, whatever this is, you need to flip it. Okay? Because whatever in parentheses always has a tendency to flip on us. For example, when we were talking about moving left and right, if this was minus 3, that wouldn't move to the left where all the negative values are on the x-axis. That would actually move to the right. It acts like opposite. All right? So let's keep that in mind. If this is a negative 3, my x value is a positive 3. So what happens if it was x plus 3 squared minus, let's say, 7? My vertex would still be negative 7 for the y, but in here I flip it, and it would be negative 3. Okay, that's one of the first and major things to recognize when it comes to finding the vertex in the vertex form of a quadratic. Okay, so the vertex is right in front of our face. But we have these two new words here. All right, we just talked about the vertex. That's right here. Big dot right there, man. You know? So now we have two new words. The focus. Okay, the focus is a point. Okay, that's inside my parabola cup, let's call it. Okay, the shape. In other words, yellow. If this is my parabola, that's kind of like a cup. You ever see the commercials where people have upset stomachs and they throw like some sort of antacid in a cup of water and it just fizzes and then they drink it? Say hello to your little antacid tablet right here. That's the focus. That is always inside our cup here. The directrix, that is a line. Okay? Our parabola never touches, or you can say crosses, the directrix. All right, so here's my directrix. All right, this happens to be at negative 3. So the equation of my directrix will be y equals negative 3. Okay, that's fine. Now, Mr. Visca here just said, and I will do this in green, my parabola should never cross the directrix. So if I erase all these marks I did right here, and I just want to show you something, and I see the blue line here is my directrix. Okay, and let's do, the focus is also this big blue dot right here. And let's say I didn't have this parabola. How do I know if the parabola opens up or if it opens down? Okay, my parabola should never open like this. How come? Because it never should cross or touch the directrix. All right? It should never cross or touch the directrix. It should always open so that the focus is inside the cup. All right, so there's 2 points that I want to mention. And you take notes wherever you feel you need to. All right? The first point, which is pretty critical, is that my vertex is always, notice I said always, there is never an exception, halfway between the focus and the directrix. Okay? The distance from my focus to my vertex is the same as the distance from my vertex to my directrix. This is the same. So if this had a distance of 1, this is also 1. That's the first point I want to mention. Okay? My distance from here to here, if that's 1, is the same distance as vertex here to directrix, 1. Those are always the same. Always, always, always. So if I have 2 of the 3 players here, and when I say 2 of the 3 players, I mean, love the highlighter, if I have the focus, the vertex, and directrix, and I have 2 of those 3, I can always find a third one. Always. Okay? That's the first thing. And the second thing is why. Why is the focus and directrix so important when it comes to parabolas? Because let's go back and realize that the parabola, yes, it's a line, but it's really a line made up of an infinite amount of coordinates, right? I have a coordinate here, I have a coordinate here, I have one here, I have one here, I have one here, and they get so close, okay, it makes a line. You see what I'm saying? This line goes, they get so close it makes a line. There is millions of coordinates, even in this little interval from 7 to -1. There are millions of dots that make up that line. Every single coordinate, okay? Every single coordinate. Let's pick this one right here. I don't know what that coordinate is. But the distance to the focus and the distance to the directrix are also the same. Okay? Let's pick another point right up here. The distance from that point to the focus and that point to the directrix is the same. Every single point is equidistance, meaning has the same distance. Every point on that parabola is the same distance as it is to the focus as it would be to the directrix. Okay? We kind of talked a lot about focus, directrix, and how it pertains to the parabola. That's all introductory stuff. If you want to rewind it and hear it again, that's fine. But we really need to kind of do some math with it and start applying it. And the application is where you're really going to get it. Okay? So let's start doing some math. And in this rectangle, we see something that says new formula. This thing right here is going to make our lives so much easier. I used to teach this a different way, and then I kind of came across this material, and this is a million times easier. When we go through it, you might say, this is still kind of tough and complex. Yeah, it's not easy math. I mean, it's easy when you get comfortable with this, and I say, memorize this. This will make life easier. The more you use it, the better it will be. But the second method, the way I used to teach this, was a lot harder. It was a lot more work. Okay, this is a lot less work. Okay, and I really like this method. Okay, so we have a formula here. It says A equals 1 over 4C. Where C is the distance from the vertex to the focus. That's going to help us a lot, okay? But what's this A here? Let's go back to our vertex form of a quadratic. Our A is the number that's in front of parentheses here, okay? So we have that. That's given to us. Every equation we have, we'll always have a y and an x as variables. But instead of having a H, and K, I will have numbers for A, H, and K. So I will have a Y and I will have an X. But A, H, and K, we're going to have numbers in for those. Okay, so let's look over here. Let's go back to this first problem example number 1. Again, Y and an X. Those will always be there. And guess what? A, H, K. All right, here's our A, here's our H, and here's our K. So based on those 3 variables, those numbers that are going in for those variables, A, H, and K, we're going to get everything we need to get right here. So first off, they want us to find the vertex. Easy. Our vertex is H, K. I know the K stays the same. It's 3. But be careful. We need to flip the value of the H. So instead of -2, it's going to be +2. So our vertex is at 2, 3. So let's plot that. 1, 2. 1, 2, 3. Okay, so my coordinate should be right here. 2, 3. That's the vertex. All right. So now I don't know if that opens up or opens down. I don't know if that opens up or down because I don't know where the focus is and I don't know where the directrix is. Remember, the focus should be in the cup. And our parabola, our parabola never touches or crosses the directrix. So once I know which one is where, above or below, I know which way my parabola is going to open up. Now, I'm looking at my A value and it's positive, so something tells me this should open up anyways. Remember, if this is positive, it opens up. If it's negative, it should open down. So this should open up. So my focus should be above, somewhere above here. All right, let me just get the arrow, dang it. It should be somewhere up here. I don't know where. Should it be at this coordinate, at this coordinate, at this coordinate? Should it be closer? I don't know. We're going to have to find that out. So let's find it out. Now, this is where our equation, which is going to be like money to us, comes into play. Remember, this value C is the distance from the vertex to the focus. All right? So what I'm going to do is this. I'm going to keep that in play here. I know that my A value, which is 1/8, should equal, always equal, 1/4C. This never changes. That's always 1/4C. But mister, what if my A value is different? So then the A value will change. But this never changes. It's always 1/4C. And if I can figure out what the C is, I can figure out the distance to my focus. Well, looking at this, okay, I know that 8 has to equal 4C. So if I divide both sides by 4, C equals 2. That's my distance to my focus. So where's my vertex? My vertex is currently at 2, 3. I have an X and a Y. My Y value determines the up and down. My X determines the left and right. My focus should be above. It should go up. So I'm going to add 2, which is my C value, and I get 2, 5. That is my focus. So we go to 2, here's 5, 2, 5. This is my focus. This is currently my vertex. Now, if I know my focus, I should know where my directrix is. Because isn't the distance between these two the same? It is. That goes up to, so it should go down to the directrix. This line right here is my directrix. Okay? That line is my directrix. But what if I didn't remember that it's the same distance? What if I didn't remember it's the same distance? I can also algebraically find this. Again, my vertex is at 2, 3. If I added 2 to my y value to go up from my vertex to find my focus, okay, let me say this again. If I added 2 to go up to find my focus, then I should subtract 2 to find where my directrix is. Now, that's just a point right here, but my horizontal line should go through that point. So my directrix should be at y equals 1. It's a line, not a coordinate. All right. So let me get this. You might have a lot of questions, but let's finish, and then we'll do it again and again and again. So now I know that my parabola opens up. Okay, so it does this. Or does it do this? Or does it go way out here and do this? How do I know how wide this parabola is? Well, guess what? Our friend, and this is the reason that this equation right here is so important to know. First of all, we had to use it here to help us find ultimately our focus, and it also helped us find the directrix, right? Because I found that C value. That was awesome, and it was real easy. I took 8 instead of equal to 4C. That's all I did. But do you know that this 4C is something special? It sure is. If I take the absolute value of 4C, in our case, isn't 4C equal to 8? 4C equals 8, doesn't it? That's what we call the focal width. That is how wide our parabola is right at the focus. Let me explain that. Let me say that one more time. The absolute value of 4C, and we know 4C is 8. Guess what? Guess where it is? It's right here. Okay? 4C is what we call the focal width. That's how wide our parabola is at the focus. And let me show you that. Here's our focus right here. So I've got to go 8 wide. So I'm going to go 4, 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. This distance from here to here is 8. So now I have my vertex, and I know it goes up and through those 2 points because that's how wide the parabola is. Whew. If you haven't done this before, your head is probably spinning. Let's recap this before we go on to the next one, all right? Because I want to take it slow. This formula here is key for everything, all right? We have an equation, all right? We have an equation. We need to find our vertex first. H and K. There's K. I need to flip the sign on H. Boom. I think that's the easiest thing to grasp. This other stuff will become easier. It's just new. All right? So now we need to find the focus. That's where this bad boy comes into play. The C value is the distance from the vertex to the focus. So how do we find that? We took our A value and set it equal to 1 over 4C. So we take our A value and set it equal to 1 over 4C. So 8 equals 4C. That's how I would solve that. 8 equals 4C. Therefore, C is 2. That's not complicated math. I divide both sides by 4. If C is 2, I'm going to go up 2 from the Y value, and there's my focus. C is 2. I'm going to go down 2 from the y value to get my directrix. And last but not least, how wide is this? Well, whatever 4C is, that's something we call our focal width. We just take the absolute value of it because we don't, if it's -8, I would still make it 8 wide. Okay, distance can never be negative. Okay, so it's 8 wide. So from this dot, right at the focus, the level that the focus is at to this dot is 8. So when I say at the focus, I mean when it's horizontal with the focus, right? It's right even at the focus. All right? It's 4 this way and 4 that way because 4 and 4 gives me a distance of 8. And then I can just connect those dots to the vertex. And I can draw a nice parabola. We'll do it yellow. That goes up like this and up like that. Let's do it again. Here's our next problem. First thing we're going to do is find our vertex. Vertex, H and K. All right, well, let's do this. If it's H and K, I know I need to flip the H, and it'll be -1, and keep the K -4. There's my vertex done. So I'm going to go to -1 and go 1, 2, 3 to -4 right here. -1, -4. That's my vertex. Simple. Let's find the focus. Oh, man. A equals 1/4C. That is so huge. And this C value is going to help us figure out where our focus is. So let's try and solve for C. Boom. Here's my A value. It's negative. And that's cool. That's fine. There's nothing wrong with that. So I'm going to say 1/-12 equals 1/4C. In order to solve for this, all right, I need to take -12 and set it equal to 4C. Those two values have to be the same. So -12 equals 4C. I divide both sides by 4. So -3 equals C. That tells me I'm going to go down to find my focus, which means my parabola should open up downward. I should say open downward, not open up downward, but it opens downward. So if my vertex is -1, -4, I'm going to subtract 3 because I'm going to move downward. So I got -1, -7. That is my focus. So let's plot that point. 4, 5, 6, 7. -7 is right here. That's my focus. Right here is my vertex. So the last thing is my directrix. Now you can say, if I moved down 3, I would just have to move up 3 for my directrix. All right, and I could draw that line there. That's fine. You can do that. But let's algebraically figure this out, and it's literally just adding or subtracting. If my vertex is 1, -4, well, I went down for the focus, so I should go up for the directrix. -1, -1, but again, it's a line, so I just want the y value at -1. So here's -1 on the y. This is -1 on the x. And our line should be right there. That's the directrix. And if we remember, our parabola never opens to the point where it would cross. So if I had my parabola do this, that's wrong. It should never cross the directrix. It's going to open downward. All right? It should open downward. Here's the last step. How wide is this going to be? Remember, and I hope you wrote it down in your notes, that 4C, if I take the absolute value of it, that's the focal width. Okay, we know that 4C equals negative 12. So the focal width is 12. That means for my focus, I'm going to go 6 to the right and 6 to the left because that would combine to be 12. So here's my focus. I go 1, 2, 3, 4, 5, 6. And to the left, 1, 2, 3, 4, 5, 6. From this point to this point, that's my distance of 12. And if I did this right, here's my vertex. It should go through this point to the left, and it should go through this point to the right. And there you go. Look how much less writing we did now that we kind of understood things and I don't have to re-explain things. Knowing this is, I am telling you, this is critical. That's why I wrote memorize this. All right, let's look. We found our vertex, easy peasy. All right, we found our vertex, easy peasy. Let's go purple because we didn't use it. Vertex, done. HK. Focus. I need to solve for C. I need to use this bad boy right here. Okay, so I set my A value and set it equal. Boom. So 4C equals negative 12. Therefore, C is negative 3. All right, so I got to go down 3 for my Y value. And I go to negative 7. Right here. And then if I'm going down 3 for my focus, I need to go up 3 for my directrix. Right here, negative 1. And then I just say, well, if 4C is negative 12, the absolute value of negative 12 is 12, and that's my focal width, which means I go 6 to the right and 6 to the left, and that distance is 12. The more we do it, the more you'll get more comfortable. The more you'll get more? Yeah, the more comfortable you'll get with it. Yeah, I teach math, not English, so don't hold that against me. If you think you're comfortable enough to try this one on your own, go ahead and do it. Hit pause, because I'm going to do this right now, okay? All right, same thing. Nothing's different here. Oh, well, I know this is my A. This is my H. This is my K. I know A should equal 1 over 4C. That's money. Love it. So let's find my vertex. Okay, I'm going to go a little bit quicker. So if you need to pause this and do whatever, write notes down or go right ahead. All right, that's my H, which I flip that. So it's negative 2. And my K, which is 1. There's my vertex. So I am going to go to negative 2, 1. Right there. That's my vertex. All right? Let's find the focus. And I know I need that C value for my focus. This tells me the distance from my vertex to my focus. So if my A value is negative 1/8, and my A value should equal 1 over 4C, then negative 8 equals 4C. And if I divide by 4, therefore, negative 2 equals C. So my focus should be 2 spots below my vertex. And that's fine because it should open downward. It's a negative value. So I move 2 spots down. 1, 2, right there. That's my focus. Now, how would I have calculated that number? Well, if my vertex is 2, 1, I just subtract 2 from my Y value because I'm moving downward. Negative 2, negative 1. And that's the point right here at negative 1 on the Y, negative 2 on the X. Boom. If I go down 2 for my focus, I need to go up 2 for my directrix. So if my vertex is negative 2, 1, instead of going down 2, I'm now going to go up 2. So negative 2, 3. Of course, that's a line, not a coordinate, so I only want the Y value. Y is at 3. Here's 3 on the Y. And that's my directrix. And guess what? My parabola Okay. My parabola does not open up because it should never cross the directrix. It opens down, which is fine because this is negative. The last thing I need is my focal width. That is the absolute value of 4c. I know 4c is negative 8. It tells me right here, 4c equals negative 8. The absolute value of negative 8 is positive 8. That's my focal width. What's that mean? That's how wide the parabola is at the focus. So the focus is right here. I go 1, 2, 3, 4, right there. And then I go to the left, 1, 2, 3, 4. Those two bigger yellow dots here are 8 apart. So my parabola starts at the vertex. It will go through this on the left, and it will go through this on the right. There you go. Perfect. All right, so we will do this last problem, and we will end this video here today, which is fine. I know. Don't cry. Don't shed a tear. I'll be back. This is a little different because my other equations, they were y equals. This is not y equals. But I am going to make this y equals. Okay? I'm going to make this y equals by isolating my y by doing the opposite math. All right? So let's start that process. The first thing I'm going to do is I'm going to divide this side by 24. The same thing as dividing by 24. I'm going to tell you a little secret here that you should already know. I could divide by 24, or I can multiply by 1 over 24, because that will still cancel. So I'm going to multiply this by 1 over 24. So now I have y minus 8 equals 1/24 x squared. The last thing I need to do is add 8 to both sides. So I am all said and done, and I will rewrite this nice and neat. Y equals 1/24 x squared plus 8. So now let's start with everything. Okay, and let's not forget our money shot here. A equals 1 over 4c. Now, my vertex is my h and my k. Here's my k, but I don't seem to have an h. Let me look at our previous problems. There was an h in the parentheses here with the x. There was an h in the parentheses here with the x. But if I look here, I don't see anything in the parentheses here with the x. Guess what? I have no h. I have 0 h's. It is 0. You are good to go. So I'm going to plot this point, 0, 8. And for the sake of size, instead of every box being 1, every unit, every line, my scale is going to be by 2's. So I go to 0 on the x right here, and I go 2, 4, 6, 8. All right? So I'm going to put a dot here at 0, 8. That's my vertex. Now the focus, I take my a value, which is 1 over 24, and I set it equal to 1 over 4c. So 24 equals 4c. If I divide by 4, 6 is my c value. So my focus, and that's a positive 6, is 6 up from the vertex. So if my vertex is 0, 8, I add 6 to go up to 0, 14. That, my friends, is where my focus is. So here's 10, 12, 14. 10, 12, 14. I did that right. So right here is a dot. That's the focus. I know this parabola opens up because the focus should be in the cup part. Now my directrix. If I went up 6 from my vertex, which was 0, 8. If I went up 6 to go to my focus, I got to go down 6 to go It's my directrix, but we know that is a line, so I only want the y value, and that's at positive 2. All right, so let's take our green marker, and here's 2 right here. So the line, that's my directrix right there. I mean, this gets easier and easier every time you do it. The only exception here is we had to get the y by itself. I get that, okay? A little bit of algebra. You should be good at that at this point. So all I got to figure out is how wide is this parabola? Oh, good thing we know what the absolute value of 4c is our focal width. And I know 4c equals what? What does 4c equal? 24. So the absolute value of 24 is 24, and that's our focal width. Which means I'm going to go 12 to the right and 12 to the left, because 12 and 12 is 24. So keep in mind, I am making these 2s, 2, 4, 6, 8, 10, 12. All right? So right here at the focus, I go out 12, which would be to this point. And then I go 2, 4, 6, 8, 10, 12 right here. Of course, I haven't said this, but it should go without saying. When you're graphing this, you don't need these little dots. Okay, I'm only putting them there so you can see as I'm talking what I'm doing. When you graph, you probably shouldn't put those little dots there. And I know, because we are getting so good at this now, that my vertex is on the parabola. This point, it should go through that point on the right, and it should go through this point on the left. That is spectacular. The way I taught it in the previous years pales in comparison to this right here. It's nutty nuts. All right, so that's the end of part 1 of lesson 9. I'll be back for part 2. Hope to see you there. Take it easy.